Problem number 11. A right triangle wooden block of mass big M is at rest on a table, as shown in the figure. Two small wooden blocks, both with mass small m, initially rest on the two sides of the larger block. As all contact surfaces are frictionless, the smallest cube starts sliding down the larger block while the block remains at rest. What is the normal force from the system to the table? Solution. First, let's draw all forces. On small cubes we have two forces acting on them. That's mg and the normal force n1 for left cube and n2 for right cube. Now let's write the expressions for this normal force. n1 equal mg cosine alpha and n2 equal mg cosine beta. Same force acting from small blocks to this triangle block. And now we just need to count what is vertical part of this normal force acting on this triangle. We have n1y equal mg cosine square alpha and n2y equal mg cosine square beta. But because we have right triangle, we have cosine beta equals sine alpha. It means that the total force from two blocks on this triangle block in vertical direction equal just mg. It means that total force from triangle block and the two small blocks on the table equal small mg plus big mg. That's the answer C. Also, we can count what is horizontal force from these small blocks on this triangle block. Left block pressing in direction x equal with the force mg cosine alpha sine alpha, and right block pressing with the horizontal force mg cosine beta sine beta, and because cosine alpha equal sine beta and sine beta equal cosine alpha, so we have a total force equal 0. It means that we even don't need to hold this triangle block. It will stay automatically. Problem number 12. A spherical shell of mass big M and radius r is completely filled with a frictionless fluid, also of mass big M. It is released from rest, and then it rolls without slipping down an incline that makes an angle theta with the horizontal. What will be the acceleration of the shell down the incline just after it released? Assume the acceleration of a free fall is g. The moment of inertia of a thin shell of radius r and mass m about the center of mass is I equal 2 over 3 m r square. The moment of inertia of a solid sphere of radius r and mass m about the center of mass is I equal 2/5 m r square. Solution. Here we can use an energy approach. Suppose that this sphere travels distance with a height difference h, and in the end the velocity of this sphere equal v. We can count what is total speed in the end using energy conservation. Total potential energy of this system 2mgh converting to kinetic energy, which is translational kinetic energy 1/2 to mv square plus rotational kinetic energy of this shell, which is 1/2 2/3 r square omega square. But because this shell rolling without slipping, we have omega equal v over r. And finally, total kinetic energy equal 4 over 3 mv square. And from here we can find that v square equal 3 over 2 gh. But from other hand, we have expression for motion which connect speed, acceleration, and distance. We have v square equal to ad, where a is acceleration and d is distance. In our case, distance equal h over sine theta. Now we can put this expression for v square, and we have v square equal to ah over sine theta. Finally, we can equalize these two velocities, this v square and this v square, and we have acceleration equal 3 over 4 g sine theta, which is answer B.